Students, let us continue our discussion on quantum mechanics. We have just finished the postulates of quantum mechanics. Now let us discuss today a more important topic, that is expectation value. So this is a video after a long time and I have decided to continue our lecture series on quantum mechanics. Basically in this channel I am discussing the syllabus of IIT JAM physics. Basically there is a different playlist for different topics. So you can find out the playlist and you can see the videos. And obviously if you are new in this channel, then please subscribe this channel also. Okay. And besides this IIT JAM physics, I have uploaded some videos on CSR net physics also, and for PGT physics I am thinking that I will be uploaded a video on, for the experience of PGT physics in different part of the India. Okay. So basically today what we will discuss very important topics of quantum mechanics, that is expectation value. Okay, so today we will discuss about the expectation value of physical quantity. Expectation value of a physical quantity, which is represented by a cap. And you know, in quantum mechanics, any physical quantity is represented by an operator form. Okay, so if there is a physical quantity position x, then its quantum representation will be x cap. That is basically the operator. So here any physical quantity means the operator form. Here in general I have taken that a cap. Now you know, we have defined already in the postulates of quantum mechanics psi as a wave function, and there are two kinds of notation. One is the Kate vector and another is the bra vector. Okay, and basically Kate and bra vector जो है basically complex conjugate to each other. So in another way we can write, if this is psi, then this is obviously psi star. This is the complex conjugate of psi. So in this notation, Kate vector means normal wave function psi, and this bra vector means the psi star. Okay. Now you know that any state, this is psi is basically the quantum state, you can say. This is the wave function. This is basically represent a state of a quantum system. And this can be represented by the superposition of many mental copies of this. Okay, so basically psi can be expressed as a superposition of a number of wave functions, which are the, we can see the mental copies of psi. Okay, so in that case we can write psi in this way. So we have already discussed this kinds of thing. So you should see the playlist and you should follow the videos one by one so that you will understand more better. Okay. So psi can be represented in this way basically, and this is psi c1 psi 1, okay, plus c2 psi 2 plus c2 psi 2 plus dot cn psi n. So this is how we can represent the wave function psi. This is called the superposition principle. Now what is the expectation value of a cap? Okay, now the expectation value of a cap is defined in this way. So this is the notation, and this is defined in this way mathematically basically. Psi a cap psi, okay, upon psi with psi. So this is how we can, this is actually scalar product. Okay, and for normalized wave function we know this scalar product is equal to 1. But this is how we can mathematically define the expectation value of, this is basically the average. Okay, and we can express this expectation value in terms of probability also. So we will see that thing basically here in this video. So this is the normal definition, and you can write it in integration form also. This basically means actually minus infinity to plus infinity if there is a continuous system. In that case, this is defined for basically discrete system, and for continuous system we can write it in this way, that will be psi star a psi, and obviously we can write if one dimension, that is dx upon integration minus infinity to plus infinity psi star psi and dx. So we can write in this way also. Okay, so this is basically the mathematical definition of expectation value, and we will solve problems where we have to find out the expectation value of different physical quantity for a given wave function psi. Okay, so we will see later on in the form of problems. But basically now what our goal is to find out this a cap, the expression of a cap in terms of probability. So how we can find out this? Now if this is psi, this is basically the Kate vector. Okay, now if we operate a cap on this, suppose we want to operate a cap in this, So there will be a cap psi in this way. So a cap will operate on each and every copies, that is here also a cap, here also there will be a cap, here also there will be a cap. So in this way a cap will operate throughout the expression for each and every term. Now this a cap psi 1, this a cap psi 1, if the measurement of psi 1, if the measurement of psi in this state is a1, here what we have done, actually we have measured psi, sorry we have measured a cap on the state psi, है ना, इस फिजिकल क्वांटिटी को हम मेजर कर रहे हैं फॉर दिस स्टेट, एंड देयर आर डिफरेंट डिफरेंट मेंटल कॉपीज ऑफ दिस स्टेट. सो इफ यू मेजर psi 1, then psi 1 is one of the mental copies, psi 2 is another mental copy, psi 3 is another copies. So these are basically, we can say, the part of psi, है ना. तो basically if you want to calculate or if you want to measure a cap on this state, then you will have some value. So suppose that value is a1. Now if you want to measure this psi for this state, so for this state the measurement will be a2, for this state it will be a3, and this is represented by the eigenvalue equation. You know, if a cap psi n, a cap is operated on psi n, then we will get just an into psi n. So this is the eigenvalue equation, you know. So now in general we can write for a psi 1, this is a1, that is a1 psi 1, here a2 psi 2, here a3 psi 3, and an psi n. So in general what we can write, here, if this is equal to c1 for this a1 psi 1, है ना. For this it will be just c2 and then a2 psi 2. Okay, similarly for this state it will be just cn and then an psi n. Okay, so this is how we can write this a cap psi, this a cap psi. Okay, this is how we can write. Now what is the bra vector? If we talk about psi bra vector, then it will be just what was psi was, this expression is after operating a cap, but before that if you want to write only psi, then there was c1 psi 1, c2 psi 2. Now when you want to write this bra vector, that means this is the complex conjugate of psi. In that case ये c1 c2 जो है, that can be also complex number. So ये c1 जो है, that will be c1 star, the complex conjugate of c1, and the psi 1 will be just, it will be just converted into bra vector because we want to find out psi bra. So it will be just something like this, something like this. Similarly प्लस हो जाएगा c2 star psi 2, है ना, ऐसे हो जाएगा. So dot dot dot, the final state is cn star and then psi n. Now what was the definition of expectation value? I am writing here, a cap was psi, a cap psi, you know, upon psi with psi. So this was our expectation value. Now how we can find out this? You have to just multiply this and this. So if you multiply this and this, so पहले ये होना चाहिए. So अगर आप ऐसे भी सोच सकते हैं कि ये psi जो बड़ा है, अगर हम यहाँ लिख देते हैं तो it will be psi a psi. देखिए ये हो जाएगा. So it will be just as if we can write this psi bra first, then a cap psi, then a cap psi. As if you can realize this is something like this. Okay, now what will be this? So पहले ये and multiplying with this. So this will be multiplied with this, this will be multiplied with this, this will be multiplied with this, ऐसे ये हो जाए. लेकिन देखिए अगर हम इसको मल्टीप्लाई करते हैं इससे, तो ये c1 star c1 that will be mod c1 square, है ना, according to the complex conjugate theory कि z star जो है that is mod z square. Similarly c1 star c1 जो है that will be mod c1 square. Now what will be psi 1 with psi 1? Now the multiplication will be psi 1 with psi 1, है ना. इसके बाद क्या होगा, देखो ये हो जाएगा psi 1 with psi 1. Now what is this? This is basically 1, because you know from the property of this wave function psi, if you know, so psi I with psi j, this is just the scalar product we have already discussed previous video कि psi I with psi j, ये जो multiplication है, ये जो scalar, ये actually this is a number basically, and ये 1 होता है if I equal to j, if I equal to j, and it will be 0 if I not equal to j. So see here, first term when you multiply this with this, then there will be a scalar number psi1 with psi1 and that will be 1. But when you multiply from here to here, so it will be psi1 with psi2, that will be again 0 because I not equal to j. Then psi1 with psi3, that will also be 0, up to psi n it will be 0. So the only term that will be survive here, the first term, that is c mod c1 square into psi1 with psi, and here one a1 is also, है ना, a1 is also here, so here a1 will be there, and this will be basically 1. So it will be just, we can write a1 c1 square, है ना, we can write this a1 into mod c1 square for the first term. Then what will be the second term? Then second term will be by multiplying this and this, so it will be mod c2 square a2, that means a2 into mod c2 square. Similarly we can write an into mod cn square. Now you know we have already proved that what is the expression of cn. So cn is basically, we have proved in the last class that cn is basically psi n with psi. This is cn. So cn square जो होगा, that will be mod of square, है ना. So this c1 square means psi1 with psi, c2 square means psi2 with psi, psi n, and this is cn square means ये तो लिखा है already psi n with psi. So now if we substitute this, है ना, so it will be just, you can see a1 into psi1 with psi mod square plus a2 into psi2 with psi mod square plus dot dot an into psi n with psi mod square. If you are facing problem with this notation, then you should see the all videos of the playlist of quantum mechanics. Then you will be very clear, because whatever I am using here I have already discussed in the previous videos. Okay, so don't worry if you are facing some problems with this kinds of notations, then you can follow the previous videos, because you know in basically in BSc honors syllabus this Kate and Brown notation are not used most of the universities syllabus, according to syllabus. But for IIT JAM problem, if you know about this notation, then the problems will be very simple for you. The problems, the kinds of problem asked in IIT JAM syllabus, IIT JAM physics in previous year, you can see if you know this bracket notation, then you can easily solve the problem. That's why I am discussing and the quantum mechanics, this part of quantum mechanics, by using this bracket notation. Okay, now if you see this a cap is just psi a cap psi, and here is psi with psi. Now if you substitute here in this equation, then what will happen? Just one psi with psi ये नीचे आ जाएगा. अगर हम a cap करना चाहते हैं इसको, तो ये what will happen here? psi a cap psi with psi ये हो जाएगा. इसका मतलब ये नीचे psi आ जाएगा. Now if psi is normalized to a function, that will be 1. But in general, we will assume that the function is not normalized. So you have to multiply this scalar product. Okay. Now you can see this psi1 with psi mod square upon psi ये क्या है? Basically a probability है. We have defined already the probability Pn जो है, that is basically psi n with psi mod square upon psi. This is basically the probability. So we can write this is P1, this with this P1, this is P2, this is P3 and Pn. So we can write this will be just A1 P1 plus A2 P2 plus dot dot An Pn, or we can simply write it as a summation An Pn. So this is how we can find out the expectation value in this way also. So instead of using this expression, sometimes we will use this expression according to the situations, according to the problem. Okay, so expectation value is not only defined mathematically by a cap is equal to psi a cap psi upon psi, but it can also be defined in this way also, because these two are the same expression as you go in this way. So this is how I want to prove how we can go from here to here, and through this process we have learned a lot of things. So this is the most important thing. Why I am proving these kinds of things? In these kinds of competitive exam, there will be no proof. They will ask, they even मतलब never ask these kinds of situations कि आप proof कर दो यहाँ से यहाँ तक. if they want to ask a very simple MCQ question, then sometimes they can say ki, what is the expression of expectation value, this or that. That will be the different case, but obviously there also you need not to prove in this way. But the thing is that the process, when I am proving this result from here to here, the process that I am following, the notation that I am using, the operation that I am doing is very useful in different problems. So when we will solve problems, you can understand why this process is very important. Okay, so for today, thank you. In the next class, we will discuss another topics of quantum mechanics, and we will complete this playlist. Okay.